Hi, for today's teardown we have this. It is a kind of item I noticed on eBay a while back, and I have been very curious about it, but usually they are very expensive. Finally, I found one broken, even very broken, at a decent price, so I was able to get one. So this is called a pipe laser. It is used on construction sites when laying down big sewer or drainage pipes. You want to install them at a precise angle in order to let the fluids flow flawlessly in them. They are some kind of electronic laser angle measurement devices. This one is missing obviously the big battery on the top, which is by itself quite expensive. We are missing a shock absorber part on the glass on the output side. So what do we have here? We have the empty battery compartment, which I am missing. We have the control panel with LCD display, controls, and some maybe remote control receiver here, something like this. You can see very ruggedized case, very strong, because it is to use onto construction sites, so in quite a rough environment. The brand is Topcon, a famous Japanese brand for pipe lasers and theodolites and things like this. There is a mark here for the axis of rotation of the laser, I believe. You can see how ruggedized it is at the bottom and how worn out also. Main power input connector here for charging the battery. And on this end, you have the laser output on the receiver. Missing, obviously, a piece of glass here. Serial number for you playing at home. Okay, let's open it. So in fact, the screws here at the bottom are new from me, because when I received the item it was already opened. And as you will see, it is not only out of use, it was damaged on purpose in order to prevent any reuse. I wonder why. It is quite sad, because I will not be able to test it, I believe. But I am mainly interested in the precise mechanics in it. In particular, we must have some kind of level sensor in order to the item be able to know when it is perfectly horizontal, and probably precise angle measurement devices. So just 1 second. So you can find many of these devices on eBay together with theodolites and levels. There are other brands, Leica, for example. I took the one I was able to purchase at an affordable price. So as you can see, very obviously here, so there is a seal for the case, okay, and look at this. The cables to the control panel and the battery input were cut on purpose from the motherboard, so it will prevent me to test it, I believe, because I do not want to resolder so many data wires. Okay, quite sad, but it is what it is. So I will put the camera over it now. So you can see the case is made of very strong die-cast aluminium, apparently in 2007. On the top here we have a moisture absorber bag. We have the back of the control panel, battery contacts, probably a LED here at the top, and the what must be the receiver side. So it works with a special reflector piece, mirror piece. Two little black areas here, probably infrared receivers or something like this. So it is what we have here. Last calibrated in 2020. And on the bottom we have the handle, we have the power input, we have two circuit boards with electronics, and we have of course the business side, all the precise mechanics with apparently angle sense encoder here, rotary encoder, laser, motors, because this thing is entirely robotized and will move by itself to measure the angles, but we will have a better look at it later. First we will start with this part and the control panel, I believe. So large display, plumb sensor button, mode selector. You will find on YouTube a number of videos showing how to use them, by the way. I will link some of them in the video description. So let's undo this control panel. We have here a lot of small metric Allen screws, which is always good because they are not easy to find and always useful to have. Actually, two of them were missing. I did replace two of them temporarily. So this thing is obviously made to be watertight, because you use it mainly outside in a roof environment. Really, I am happy to at least be able to take one apart. Very, it was full of sand and dirt and things like this when I received this device. The screws were even blocked by dust. I had to dig them out. So as you will see here, not much, just a PCB for the buttons on the display, I believe. On this mysterious area here we will try to figure out. So, one more screw maybe, this one, ah yes. What do we have? This part is apparently reinforced plastic. Nothing else. We must have a seal somewhere, and let me grab a knife here to extract this part. Okay, quite reinforced. Interesting. You can see how it is made. We have contacts here going to the back PCB here. We have a flat flex. So this is obviously just LCD control board with flat flex here for the buttons. So regular off-the-shelf LCD driver, probably, more or less. So nothing in particular here. We have little PCB here, which I will extract. So usually when you extract this PCB you need to disconnect it, but here obviously because the wire harness is cut away, it will come out directly. Nice Japanese screws here, very regular. Okay, we have big connector. Oh, there is still one piece of wire attached. This thing was really butchered. Look at this. So what do we have here? We have this little PCB, yes, 2007. Some coils, connector, a few little ICs. And in here apparently we have 4 what seems to be LEDs. So it must be some kind of light to indicate something to the user. Oh no, they are some kind of, there is a mirror and not less than 4 infrared diodes. So long distance infrared receiver or something like this. They are probably worth retrieving these diodes because they seem to be quite special. Not a package I did see previously. Yes, very unusual. For sure. It was like this. Yes, okay, there is a mirror here. This must be infrared transparent plastic. So I will keep them for sure. Then we continue with the apparently receiver sensor. Part here in the top. That will be interesting. I expect more weird infrared or light sensors at least. I can see already a pretty serious shielding piece. Okay, do we have connectors? Yes. Okay, so here I will clean it because I will put it to a scrapyard, but nothing left except for the battery contacts. So this thing obviously, yes, I see 2 more, probably the same model of diodes, photodiodes. Serious piece of shielding at least. Let me undo it like such. Maybe, maybe not. I am not sure. Maybe it is. There is one more screw, by the way, which is hidden behind this. Okay, at least I will retrieve a number of little screws, which is always interesting. Okay. We have one more shielding, one more date code, and 2 more screws. That will reveal this little PCB with very Japanese GRC ICs. Also as mount, you can see little bulge here with a inductor, it seems, and okay, 4 infrared receivers going into this plastic part. So it appears to be black plastic, but in fact it is transparent to infrared. At least here and here it is clear windows. So this is the receiver section for the laser beam reflected from the mirror at the other end of the pipe. Okay. Good. We continue with the electronics. I will disconnect what remains from the connectors here, and here you can see a number of connections going to the sensor part. Okay, more Phillips screws. Come off like such. Nothing behind it. So we have here a sandwich of 2 circuit boards with, you can see, mainly a lot of little surface mount ICs, analog ICs obviously, number of them. Let me grab a small screwdriver. So it is a shame about the cut wires, really. Okay, so on the top board, called the power board, main Japan of course, lead free, big capacitor, relay, and you can see all these parts, bottom side of it. So this is responsible for driving probably the motors in the mechanical unit, and the laser, and receiving the return light, and amplifying it, whatever. And here we have to see what seems to be the brains board, neck, probably processor here, crystal. This must be maybe a firmware, we have a sticker on it. Interesting, you can see QR codes on the sticker here. Some test points. Lead free again, and it is called the CPU board. Yes, so we have a little CPU here. Very Japanese design, you can see. Okay, we are left with the main area of interest. The main mechanical and sensor unit. So I can see 3 motors with speed encoders. So what do they do? This one will rotate the whole unit on a vertical axis, you can see like this. Now you have here a rotary encoder, obviously. This one, I am not sure what it does. Maybe it does the same thing, yes, but at a very slow speed. You can see it is rotating this here. And yes, it is also adjusting not the laser part, but only this part, which I believe is the level sensor, while the other one here will move both at the time. Okay. And we have another one at the bottom here, which is rotating it left and right. So it will be able to aim precisely. Okay, you can see here already nice optics with a mirror, prism even. Okay, very interesting. So let me try to start to take it apart. We have this upper frame piece in reinforced glass fiber reinforced plastic. Very unusual stuff here. If I find another of these devices from another brand at a correct price, I will pick it up on eBay, and we will do another teardown of another model. Okay, super nice ball bearing here, worth keeping for sure. And okay, it is coming off except for one spring here secured to the case and a few wires. Okay, one second. So as you can see, here we have at the bottom one other ball bearing as expected. Very nice one. We have the left and right motor like this with speed encoder here, infrared, little infrared sensor with little disc with slots, and we have one feedback linear potentiometer like this. Interesting. So it makes the whole thing makes a servo motor. But here is the main area of interest. As you can see, a lot of stuff in here. I am trying to figure out how to take it apart. It will be quite complicated, but this part actually is only a optical piece with prism here and laser diode here somewhere, and it is all in one piece. Will probably be quite tricky to take apart. What I am interested in are these two black boxes. One here two screws. So one must be the level sensor and the other one will be probably the readout for the encoder disc we have here. You can see the disc in glass with the slots. And we have more stuff in here. So first this box. Little box which seems to be glued together with sticky tape, by the way. The cover is glued. I want to open it. Try to, at least, without stabbing myself, if possible. Okay. Okay. Oh, very nice. I believe we have here just. I wonder if I will be able to show you it, but in fact it is nothing else than an electronic level sensor with. I need to solder the LED here, by the way. I do not want to damage it. We have something here. Okay, so what I can see, we have a little vial here with a bubble. We have a LED here, and we have infrared receivers here. So the LED will shine through the vial of bubble vial like a regular level, and the sensors here, infrared sensors, will detect the position of the bubble, and it will figure out if it is horizontal. It is called the rolling tilt board. So very interesting stuff. I was not expecting to find such a design in fact, but it is maybe possible to reuse it, so I will not damage it any further. Really interesting. We continue here with whatever other things we have. Here it seems we have something in this area, so I will try to remove it. At least they did use only one size of Allen screws. Okay, we have one more LED shining through a mirror, and a readout here made of what seems to be a linear CCD sensor. Nothing else. So it must be part of the readout for this rotary encoder. Will it come off or not? Huh. Maybe not, because it is stuck all together. But you get the idea. A linear CCD sensor here, reading this piece of glass with all the little slots you can see here. So it means this unit here must be the remaining level sensor. It is secured by two slotted screws this time. Why slotted screws? I have no idea. By the way, you can see the very nice mechanical designs here. It seems like a gyroscope almost. Look at this. Look at all these parts to retrieve. Nice Allen screws and everything. One more feedback potentiometer here, by the way. And this PCB will be your laser diode driver. You can see the 3 pins to the laser diode here. And you can see it here. So this must be another angle sensor, well, level sensor. Probably, okay, yes, it is the same thing. Another time, little vial with a bubble, liquid on the bubble, and the same setup. You can see the bubble here. So really interesting design, this thing. I was not expecting this kind of construction. Really worth taking apart. Just for the nice parts I will retrieve from here, motors and everything. But here we can see everything already. Really nice. And by the way, the motors are Maxon Swiss made in the Japanese equipment, which is pretty interesting. very expensive on well-made precision motors. Okay, so this is all I guess for this thing. Really an interesting device to look at precision stuff all over the place. Nice parts and unexpected sensor technologies. So thanks for watching, bye bye.